moving to the first contributed talk of the day. Right now, we will have the pleasure of listening to Elena Baum from Moscow University, whose talk is titled Educational Innovations of the Chemical Faculty of Moscow State University, MSU, in the History of Chemistry Teaching, cooperation with the Museum of Science.
The name of my presentation you see on this slide. And to begin of my paper, a short digression into the history of teaching of history of chemistry at Moscow University. Reading history of chemistry courses at Moscow University is a long-standing tradition. As early as in the 19th century, beginning from 1890s, the university began offering courses in this discipline. Here you see the names of some courses and the authors of these courses, between them famous Vernadsky and Walden, Paul Walden. The early 1920s known to have paved the way for politicization of historical sciences and the humanities. During the Soviet times, a new chair was founded at Physical and Mathematical Department of Moscow State University in 1926, the chair of History and Philosophy of Natural Sciences. The head of this chair, you see here, was Maximov. An important in 1928, Assistant Professor Ivan Petrovich Rodsen took charge of this chair. An important positive aspect of Rodsen's leadership of the chair became a reading of specialized courses in history and philosophy of relevant disciplines, chemistry, mathematics, physics, biology. On this slide, you see the teachers of this chair, but you see most of the teachers died in the middle of 30s years. Indeed, everything changed in the middle of these years. There began repression, arrests, persecution. There was never-ending staff reshuffling linked to repressive pressure, which eventually would result in the chair shutting down in 1936. The new stage, the revival history of chemistry teaching and research in this area began in the middle of 1940s. As after the Second World War, you understand, as Nikolai Alexandrovich Figurovsky came to the chemical department after discharge from the army. In 1947, he founded the chair of history of chemistry, the first one among similar designated chairs at the university. Upon taking charge of the chair of history of chemistry, Professor Figurovsky read the main course in the discipline for almost 40 years. Teaching programs are constantly changing in the university, and I can show you the parallel between them. In the 1920s, 30s, in the history of chemistry course, much attention was paid to the philosophy and methodology of chemistry. This approach was later revived in the lectures of Professor Zorky, who headed the teaching of this scientific discipline after the death of Figurovsky. Namely, an important place in it was held by the methodology of chemistry, the discussion in its contemporary version, and the historical aspect of the fundamental concepts and crucial methods and approaches used in chemistry. And a new educational, I know it, paradigm of practice-oriented teaching of chemistry has been developed and is being developed in last years under my guidance in two institutions, Moscow State University Chemical Department and Chemical Department at the Baku branch of Moscow State University in Azerbaijan. In our teaching program, we pay special attention to the issues of development of chemical tools in the process of the evolution of scientific knowledge. Here in my paper, I discuss the result of inserting of the new educational project. We name it to the history of chemical instruments and chemical technological processes, which we use for this new program for teaching history of chemistry, implemented at the Chemical Department of Moscow State University with the assistance of the Moscow Museum of Science. We name it Polytechnic Museum. In the course of history of chemistry teaching in the last 5 years, as well as the effectiveness of the usage of visual content, educational film for the same purpose. Excuse me, it's too early. Essentially, the history of chemistry course as the program developed in the last 15 years was intended to provide attendees with a system of historical chemical data that would be able to consolidate knowledge obtained by the students when learning different chemical disciplines into a single conglomerate, I can say so. Its main goal, according to the program, was to demonstrate historical and logical interrelation between the most important events and discoveries in different sub-disciplines of the chemical science and allied disciplines, introduce students to the work of prominent scientists, their contributions to the development of certain areas of chemistry, whose progress, according to modern historians of science, for example, I can mention Peter Morris and his books, largely consisted in improvement of chemical tools, experimental techniques. Since chemistry is a science based on experience, wherein an experiment is not just a research method, but a source of a new knowledge and simultaneously an object of study. In some aspects, it is the experiment that became definitive in substantiation of appearance of new lines of research in the sphere of chemistry. This approach is reflected in our tutorials. This year, there will be a new edition dedicated entirely to the whole 19th century. And in number of lectures, I demonstrate in sufficient detail how development of a certain measuring equipment facilitated the shaping of modern scientific practices and emergence of new areas of chemistry. Thus, for example, it is obvious the development of thermometry is in the 70s and 18th century. You see here the work on improvement of Galileo's thermoscope, development of thermometer version by Fahrenheit, Celsius, Reaumur, and others, facilitated the emergence of thermochemistry, or the development of the gas burner by Robert Bunsen played the key role in creation of the method of spectral analysis that signified a new era in the evolution of chemistry. And about the film which we have created. This film I made together in collaboration with the Polytechnic Museum and MSU Faculty of Journalism. and it is dedicated to the evolution of laboratory chemical tools. Students can learn about scientific realia of certain historical periods, compare the equipment of a modern chemistry laboratory, where they have practical training. For example, this with that of laboratories in early centuries. The film discusses exhibits of the Polytechnic Museum in Moscow and famous European museums in history of science. And on the next slide, you see here my teaching experience in the Baku branch of Moscow State University, where I use this film. In addition to lectures, students watch the above mentioned film. They not only watch the film, but also write a test work on the issues reflected in it, taking into account their homework in this direction too. Preparing for the test, students master a certain data array concerning the current state of chemical laboratory instruments. Indisputably, the lectures, and especially the produced film, successfully visualize the instrumentation equipment under discussion in its evolution. But still, this body of knowledge is somewhat virtual to students, I see. And it is a different story when students themselves are directly involved in learning the history of experimental principles of the discipline of chemistry. Such a practical study of the scientific toolkit, study of its contribution to the evolution and expansion of chemical experience and knowledge are possible only with studying museum collections. A science and technology museum has always been and remains a powerful source of knowledge and demonstrates the special role of the experiment in chemistry. As the artifacts are included in museum space, a real-life object lose their day-to-day relevance and become a sign capable of communicating the information content embedded therein. That is why museum collections are convenient to use for scientific research as well as for teaching. A student involved in the research process of authenticating certain museum pieces have to modify their usual perspective on understanding of the meaning of a certain object. Quite natural, there appear questions they are not used to, such as you see, I wrote it's on this slide. As part of the work in our project, students find answers to them. Our project got its start up in 2018. It included students of the Faculty of Chemistry studying the rarities of the Polytechnic Museum in the area of chemical tools for extra credit in the history of chemistry course. A twofold objective was set for participants to some extent authentication of pieces held in the museum's repository collections, but mostly the objective of uncovering their historical significance, extending the museum's documentation on selected artifacts. The regulated sequence of principal stages of project implementation is as follows. You see 4 points, and I gave the comments to every. The first one, Employees of the Polytechnic Museum select artifacts for students' research. According for a provisional agreement, they suggested 12 artifacts in the beginning, and the next years more than 20. Including between them were chemical tools, such, for example, as Renault colorimeter, several versions of pH meters, and so on, and prototypes of a number of engineering processes. Engineered Dubrovai's cracking, salicylic acid production shop flow, ammonia converter, and others. Each participant in the project is free to choose the subject of research according to their scientific interests and personal preference. Main research problems faced by the participants included the following aspects, and you can see it's here. In the course of research, students try to answer the key questions determining the scientific and historical significance of the reviewed artifacts. Who made a certain artifact they are studying? Propose the technology of the chemical processes under examination, what technical parameters corresponded to them, what part a certain artifact played in the involvement of history of chemistry, and what interesting facts are related to their application. The third point, during research, each participant had to compile their own pool of sources on the specified subjects. Students had to familiarize themselves with a multitude of professional, scientific, and historical works, including encyclopedic and patent information. And the fourth point, then using various information sources, the project participants write a research paper, we name it a historical essay, covering the main aspects specified in the point 2. And end of this term, the last stage of certification for all participants is the presentation of research in the framework of the Student Scientific Practical Conference. We organize every year Chemical Department and Polytechnic Museum, you see on this slide. The best, a moment, on this slide you see an excerpt from one student's work on colorimeter, which I mentioned above, colorimeter attribution of 19th century Renault colorimeter. The best student.
You have 5 more minutes.
I finish, yes, in 5 minutes. The best student works performed within the framework of this project have already been published in the issues of the Chemistry in School magazine for year 2019, and in issues of journal Analytics in the next years. This slide shows the pages of the latest publications of these years in the field of the history of chromatography. To my conclusion, the project implementation adoptively promotes progress of studies of museum collections and professional advancement of the students themselves. At the same time, in the process of academic pursuit, students build up skills of independent search and retrieval of information. The body of science is enriched with new knowledge useful for the performance of professional functions, drafting literature reviews and study design on a specific topic, formatting references, participation in academic discussions, skills to present results in academic papers. At the same time, learning such retrospective information facilitates a better understanding of the principles of the chemical science, the continuous connection between the past and the present in its evolution. Thus, the experience in implementation of our project demonstrated the new educational paradigm of application-oriented teaching of history of chemistry in higher education institution can become one of innovative formats of interaction between science and technology museums and their audience. Thank you for your attention. I had before the real link to my film, but now it doesn't work in YouTube because these sanctions which we have now. But you can look in another, but not whole the film, but only that is trailer of this film. Thank you once more for the attention.
Thank you very much, Elena. Questions, please. Remember, choose the reaction of raising your hand if you have any questions.
Or you can write, because we have no time, as I understood. You can write your questions separate to me in any case. Michelle. Yes.
Hello. Yes, it was very interesting.
Congratulations. Congratulations to, sorry, Michelle. Congratulations to Elena. I think you have touched a very important point in chemistry, which is the use of chemical instruments. Congratulations.
Thank you. Thank you.
Yes, I think it was a very interesting talk, and I have even a very modern example of how chemistry has advanced in the laboratory with which I'm associated, where they made a machine they made a sort of robotic machine to make small samples, and it sped certain things up very, very quickly. And then that was no longer the weak link in making the analysis. And now they decided to use computer intelligence in order to now make some, so in other words, with the speed up using a machine, what happens is that the weakest link or the slowest part of the whole process of understanding what's going on changes. And therefore they're now going to try to use computers in order to do part of the analysis that before they used to do by hand or just visually, they just looked for correlations. So it's a very interesting approach, and congratulations on your program.
And I can say you, my comments, 2 last years, I prepared a special course under the name The History of Chemical Instrumentation, Description and Attribution of Artifacts in Museum Collections. And I have a lot of students which share this course also. That is close to our common teaching.
We also have a question from Alfonso. And we have a question by Gustavo in the chat. But so, Alfonso, can you
oh yes, sure. I mean, just I already made that to say to I'll contact with you later in another occasion because it's very interesting. Thank you. That's all.
That's all. Thank you.
And before we leave for the break, there is a question, as I said, by Gustavo in the chat that says, have you considered expanding your projects to include museums from different countries in order to increase the number of items available for students and to allow students from other countries to take advantage of your museums?
Expanding your projects. A moment, once more, it is not so quickly. it can be. I know which situation will be now. You understand, the political situation is changed. But I can say you that before we contacted with different museums in the world, and we asked another scientists to help us to attribute our instrumentation and so on. Maybe it can be, but only the situation. I don't know what to do because we cannot contact with foreigners. That is a problem now.
Maybe in a brighter future.
Yeah.
Thank you, Elena. Thank you, everybody.